Bismillahir Rahim. So let us consider unordered sampling without replacement. So in unordered sampling, the order is not important, number one, and number two, this is without replacement. It means that if we choose an object, we cannot choose it again, right? If we pick an object, so we cannot pick it again. So this is the same as a combination of n things taken or at a time. This is the same as combination, because in a combination also the order is not important, and this is without replacement. So this is same as combination of n things taken or at a time. Note that with permutation the order is important. Permutation is an ordered sampling without replacement, and a combination is an unordered sampling without replacement. So the number of ways to choose unordered samples of or things from a set of n objects is given by the binomial coefficient n or. The number of ways to choose unordered samples without replacement of or objects from a set of n things is given by the binomial coefficient n or, right? And that is equal to n factorial divided by r factorial divided by n minus r factorial. So this can be best explained with the help of an example. For example, consider this set sample space with the three letters A, B, and C. If we take r is equal to n, that is the combination of three things taken three at a time, so it will be only 1 3 3, that is 3 factorial divided by 3 factorial, 0 factorial here, and this is 1. So for example, we can have this combination A, B, C, and another permutation, for example A, C, B. This is a permutation, not a combination. This is the same combination, right? And then we can have B, A, C, B, C, A, C, A, B, and C, B, A. All these are different permutations, but the same combination. So all these are 6 different permutations, but the same combination. Because you see, the order is not important, so A, B, C or A, C, B, in whatever way it is written, in whatever order it is written, it is still considered as the same combination. So all these 3 permutations are one single combination. To further explain, if we take r is equal to 2, for example, if we choose 2 objects from this sample space of 3 things, this sample space of 3 things, if we choose only 2, r is equal to 2, then that is combination of 3 things taken 2 at a time. So this is 3 factorial, 2 factorial, and 3 minus 2, 1 factorial, and that is basically equal to 3, right? So there are 3 ways in which 2 objects can be chosen from this sample space of 3 things. So for example, we can have A, B, right? We can have A, C, or we can choose, for example, B, C. right? These are the three possible combinations that can be made from these three things. So note that AB and BA, these are different permutation but the same combination. Similarly, AC and CA, these are different permutations but the same combination. And similarly CB, again it's the same combination though they are different permutations. So basically three combinations are possible. So if we consider permutations, then permutations of three things taken two at a time is given by 3 factorial, right, divided by 3 minus 2 factorial, right? So that is basically 3 factorial, and that is 6. So 6 permutations are possible, which are listed here, right? So these six are permutations, but if we consider them combination, so this is the same combination, and this is the same combination, this is the same combination. The combinations, number of combinations is 3. So from the set, to repeat again, from the set of this sample space of 3 objects, only 3 combinations are possible. But if we consider permutations, which is ordered sampling without replacement, so 6 ordered sampling without replacement are possible, and 3 unordered samples without replacement are possible.